Welcome to Talking Science. Dr. Benjamin Pope from the University of Queensland is here to discuss unexpected radio waves potentially coming from hidden planets. Ben, thanks for your time.
Well, thanks for having me.
This is Trekzone's Talkin' Science. And you can get exclusive behind-the-scenes info and first-play access to all Trekzone podcasts by becoming a member today. Click join on every Trekzone video on YouTube. Go to thetrek.zone/support or scan the QR code on screen throughout the show. Now, it's back to you, Matt.
Well, thank you very much, Ross. And a quick mention of our socials. Trekzone's on YouTube, Twitter, Facebook, Instagram, and your favourite podcast feed. Find us, like, follow, and subscribe. Leave comments and ratings. It will help us convince the almighty algorithm we're worth it. Ben, you and colleagues from the Netherlands have used their national observatory, Astron, to search for exoplanets, and it seems as though 19 red dwarfs are telling you a little more about themselves than expected.
Yes, no, we're super excited. So we used the world's most powerful radio telescope, LOFAR, to search the whole sky, or at least a large section of the sky, for radio waves from M-dwarf stars, that is red dwarf stars, the smallest kind of star. And quite unexpectedly, we found many radio bright, but circularly polarized, that is, you pick them up with a circular antenna, radio sources. Now, what's quite exciting is this is exactly what Jupiter looks like if you look at it with radio glasses on. So radio telescopes looking at Jupiter see circularly polarized radiation from its interaction with its moon Io. Io is whipping around in Jupiter's magnetic field, and it's driving this powerful aurora that you see with optical light, but you also see powerful radio waves. And so we think what we're seeing is a scaled up version of the Jupiter-Io interaction around these other stars.
It is very exciting. And while we know that other planets here in our solar system emit radio waves as well, and that's their magnetic fields interacting with solar winds, this is the first time we've detected them from exoplanets.
Absolutely. This effect has been predicted for a very long time, but never yet been observed. And this is a really, exciting for two reasons. One is that we now have a new radio window to look for exoplanets. So everything so far has been done in the optical. Now we have radio astronomy can join the action. And with the square kilometre array coming up, of which LOFAR is a prototype, you'll get 10 times more sensitivity and a much wider field of view. So we expect to find hundreds of these. And the other really exciting thing is that these radio waves indicate that the star is interacting with its planet, and that this interaction could lead to radiation being dumped on the planet, which strips away its atmosphere and renders an otherwise habitable world uninhabitable.
Well, Ben, why were red dwarfs the focus of your study here?
Because they're very, very common, and they're very, very close, and they have a lot of planets that are very close into them, which means they actually have a very high probability of interacting magnetically. On the other hand, the sun, our planets are many times further away from the sun than these planets are from their star.
And one thing that I've noticed as I've been covering exoplanets here on Talking Science over the last few months is that the understanding of exoplanets is gaining in leaps and bounds, is gaining momentum in leaps and bounds from these things that we postulated a couple of decades ago and didn't quite understand, to now finding them pretty regularly, and it becomes just a regular occurrence that, oh yes, we found another one. But this is certainly a unique way of doing it. As you say, radio astronomy can jump in on the action now that's been hogged by optical astronomy, and
Absolutely.
I guess makes it a little bit easier to find these planets in the comparison from radio to optical.
Well, I think it's less about it's going to be an easy way of finding planets, because even with the SKA, we're going to find hundreds, whereas tens of thousands of exoplanets are known thanks to surveys such as the Kepler Space Telescope. So it's not going to be a way of finding lots and lots and lots of planets, though we will find many, so much as seeing their physics. Being able to measure this magnetic connection between the star and the planet is actually, radio is the only way to do this. And this means it's a powerful new tool for understanding habitability. Lots of M-dwarfs have these planets in short orbits. M-dwarfs are faint, so these short orbits have Earth-like temperatures. But what if they're all scoured with intense radiation from their star? So that these otherwise balmy rocks are actually uninhabitable and drenched in radiation.
And further study has ruled out planets bigger than Earth being around these red dwarfs. So if they're there, they have to be smaller.
Wonderful.
As you say, they're
Yeah.
possibly being bombarded by radiation as well. So I guess another form of these exoplanets, another type of planetary body that's out there and doing its
Hmm.
own thing.
Absolutely. Yeah, no, we'd love to be able to actually confirm these with other methods. I've spent a lot of telescope time trying to chase it down. And the best we've got is about 1.2 times the mass of the Earth as an upper limit. But there's plenty of. We wouldn't detect the Earth, and we think that this radio signal is consistent with something about the mass of the Earth.
It is very exciting research. Looking forward to hopefully getting some more data on these red dwarfs, focusing in on your attention. Ben, thanks for beaming in on this edition of Talking Science.
Thanks. Have a good day, mate.